Hello everyone. So welcome again. So today I'm kind of finalizing my part 3 session for React concepts. And without wasting time, let me quickly jump into this session. I would like to highlight the very important thing is that part 1 and part 2, where I have covered all concepts of JavaScripts, like from 1 to 12, which is memo, lazy loading, use callback, strict mode, keys, pure component, dynamic import, context API, should component update, profiler, virtual DOM, and use effect cleanup. So for all those, I have already created very interesting videos and session. I will post the links to the description of those videos, links to the videos in the description of this comment section for this video. And from there you can watch. It is very important to watch all, because then only you will get the complete gist of um, React concepts, which are very, very important. And believe me, these are very important concepts, because if you're a React developer, you're doing coding in React every single day, you definitely need those concepts handy with you, so that for review comments, for writing good and clean code, quality code, those concepts can be taken care. All right, so without wasting time, let's jump into today's very important concept, which is called, yeah, you get it right. It is called debounce and its importance. So before I jump into the code and try to explain you what is debounce, let me tell you some debouncing, like what debouncing is. Does it mean? So debouncing is a programming technique. So yeah, debouncing is a programming technique used to limit the frequency of a function's execution. So frequency of the function's execution. So in the provided React code, if you see here, okay, we used something from Lodash, which is a library. Okay, so Lodash this underscore. Um, then we called this, for example, over here dot debounce. This is used to wrap a function, ensuring it is executed only after a specified delay. For example, over here 500 milliseconds um, after the last triggering event. This is very important to understand. So this will be executed only after the last triggering event. This means that if the input value changes rapidly, over here line number 13, example, let's say the user types very quickly, so the handle input method functions will not be called immediately, okay, with each keystroke. Instead, it will wait until the user stops typing for 500 milliseconds before the function is executed, because this function is using a concept of debounce. So yeah, this is the concept of debounce. So debounce, as I said, is very crucial in scenarios where frequent function executions can cause performance issues or undesirable outcomes. For example, let's say Google search engine, right? There definitely has to be some uh, debouncing scenarios, because it's not every time that you need to make an API call, right? So for example, uh, where frequent function execution can cause, you're just writing and making complete word, so you want your search engine to perform the search when uh, only when your word is completed, when you are done with writing a full word, or let's say full sentence. So in all other scenarios, you do not want undesirable outcomes. So because those, if let's say for every keyword you hit, you making an API call, that does not make any sense. You're just wasting resources. So that is why it is very, very important concept, right? So I would like to explain this debouncing with a real life analogy. So for example, let's imagine you are you're pressing a doorbell in a rapid succession, right? So instead of answering the door each time you press, the homeowner decides to wait for 5 seconds after the last ring before coming to the door. This way, even you press the doorbell multiple times quickly, they only answer once. Similarly, debouncing here, it prevents a function from executing multiple times within a short span, ensuring the efficient event listener. So, for example, it prevents repeated execution of expensive operations like resizing or scrolling. I mean, this is a very important use case. For example, any web page, when you scroll down and when you resize a window, or let's say a browser window, there has the events that executed, they are, you know, infinite events, I would say. Not infinite exactly, but yeah, there's so many events which are executed the moment you scroll. So you want your event listeners to be executed, let's say after a delay, after a pause. Then only this concept is very important for validation. So avoids excessive validation logic execution while typing. So for example, let's say there is a form and you want to validate your email IDs or something like that. So instead of having your validation logic to be executed after every keystroke, you can have a logic. Let's say it waits unless you just are done with the format of email, like @gmail.com. So once someone is done with gmail.com, then only the validation should trigger, right? You save a lot of network overhead, or let's say anything which is connected to the validation logic. So yeah, so that is exactly debouncing. And over here, if you see handle input, okay, and this is one of the examples. Let me quickly show you in the console how exactly it looks. So in the console, we have right here. Yeah, so this is one of the example where we have a very plain and simple demo for debounce. So let me quickly explain you with the browser and the console. So you see here, let me open the browser quickly. So in the browser over here, I click debounce. So you see here when I click debounce, there is this input box comes in, okay, and if I'm writing into this input box, so you see this JD, and let's say if I write J, so see this, I'm writing J, but once I stop, then after certain milliseconds, this is printed, right? So for example, let's say I'm writing it, I'm and then when I take the hold, then it is printed. So not with every keystroke. So not with every keystroke. See, I'm pressing every keystroke. There is no console output. But once I'm done, after a certain delay, I mean milliseconds delay, this is all printed. So this is all happening because I have a debounce with 500 milliseconds. So let me quickly remove this debounce from here. I remove this debounce. Okay, this is not required. And if I run the same program, and now you see I clicked on debounce, and now let's say if you see here every time I'm clicking a button, this handle input method is called, right? So this is what exactly is the use case. You do not want to get the execution of this handle input after every keystroke. So let's say if you want to, so for example, if I just put debounce again, so let's say we want this method to be handle input method to be executed only when you are done with the typing. So for example, this, and when I stop, then only it's executed, right? So this is the very common example of debouncing. I hope you understand the concept of debouncing, which is a very common concept. So, I mean, we have Lodash library which has debounce. There are many other libraries which are. So, for example, you have something called use debounce as a hook, which you can just install npm install use debounce, and it also simplifies many things. You can use debounce as a hook. Also, you can also create custom use debounce yourself. Uh, but yeah. This is the basic concept which one should know about debouncing, and this is a very important concept which plays a very significant role in performance and optimization of network API calls, unnecessarily API calls, and it saves a lot of time for resource and CPU uh, cost. So that's pretty much all from debouncing. Let me quickly jump to the other interesting topic, which is called use transition, which is also a very interesting topic. Use transition. So I don't know how many of you already know this. So use transition is, I mean, you can easily see that this is available in React library. So yes, use transition is a React hook. It is introduced in React 18, and it is a part of set of features designed to help manage concurrent rendering. Yeah, so this is a very important concept in React, which is called concurrent rendering. So the main idea here is to prioritize updates so that some changes like immediate, which needs to be rendered immediately, like user interactions, they can take precedence over others, like updates to less critical parts of the UI. All right. So When you want to prioritize updates and rendering as well, you are going to use transition. This plays a very significant role. I'm telling you, when I show you the console logs, you will understand what exactly I mean. All right. So when using use transitions, you can mark certain updates as non-urgent or transitional. So, uh, for example, these updates can be delayed slightly so that more important updates like clicking a button or typing in a text field, they smoothly happens and they are very responsive to the users. So this is where the use transition hook, React hook is used for. So it is designed to help and manage concurrent rendering. And the main idea is to prioritize updates. So you can prioritize updates based on which updates need to be rendered faster than the other updates. So everything which you see in any concept, in any framework, in anywhere in the real world is connected to real life. So see, even the scientists, even the developers, coders, these whatever they code, whatever they invent, they all are connected to real life. So every concept it can be correlated with real life. So I would like to definitely explain this use transition hook with the real life analogy, which will definitely make an impact for understanding for those who really want to connect to the real life. Okay. So imagine you are at a busy coffee shop, okay? Barista. So the barista is busy making coffee, performing updates. Urgent order, a customer walks in and urgently asks for water. The barista stops making coffee and quickly serves the water, immediate priority, right? Transitional order. So meanwhile, another customer ordered a complex drink that takes time to prepare. Transitional updates, the barista continues with the water first and delays the complex drink until they are free. So, what exactly this? In this analogy, you see an urgent order which was water, high priority updates like clicks or keystrokes are handled immediately, right? In complex string, traditional updates such as rendering large list or performing less noticeable changes, they can wait. Okay. So barista React scheduler ensures everything happens smoothly. And this is how you can correlate, right? So use transition helps React act like a barista by prioritizing updates effectively. So if you see this code, so behavior in the code, when you click on handle, like when you handle click, function is called, the state update set count, which is here. All right, so this set count is wrapped in the set transition, isn't it? Yes, it is wrapped. So React makes this update as non-urgent. Okay, this update is non-urgent. So the is pending flag is set to true while React is processing the update. So you see here, this is pending, this flag is set to true while React is processing the update. So can you see in the console? Let me quickly show into the console and then you will understand it in a better way. So we have this uh, use transition. So you see here, uh, when, okay, let me click on increment. So you see, updating, right? So this updating after a certain delay, this count 12 is rendered. So what is happening? Even though you are clicking on increment, right? This state count, which is right here, this is not getting rendered, right? But ideally, what should happen when you click on handled, this set count actually, it should immediately update this count, and count should on line number 18 should get immediately rendered, but it's not happening because you see here the set count logic is wrapped into start transition. Okay, this is a use transition step. So you did that, and because of that, no matter what you click on this, there is something which is happening. So updating is happening. So whenever you are clicking on add button, so is pending just started, and this is the reason why you have updating, and after certain delay this count is rendered. So this line over here, this is rendered only after certain delay. Okay, and that delay, for example, I simulated this, so this is just for delay. Okay, so this will be only rendered, so I can remove this, but I just introduce this so that you can see this updating in real action. So you got this, right? I click on this, it is incrementing, but it will only update after a certain delay. Now let me quickly remove the this logic, okay, and then see what will happen. So I just remove this. I remove this, and I just make this method. Now, just uh, see, I have this handle click, and this is a set count, and let me quickly remove this also. Now, if I click on use transition, if I click this, see, it is updating immediately. You see, this is updating immediately. All right. So, because there is no concept where I have used set start transition. So, use transition, this plays a very crucial role when you want your, let's say there is a application in React, and there is a page. Okay, in that page you want some updates to happen very quickly, like immediately, and some of the updates you want to go, they can take time, like it's okay to be rendered with a bit of delay. So then you can go for use transition, you can use it, and it will definitely going to save a lot of rendering time, uh, taking the precedence over others which are not important to render immediately. So I hope use transition is clear. With this, let's move to the other topic, which is called tree shaking. So I would try to explain this tree shaking with whatever knowledge I have. No code here, because I think it's better to explain you in real way, explaining the concept here. So tree shaking, okay? Tree shaking is a term which is used in JavaScript, or let's say used in the context of JavaScript's bundlers like Webpack, Rollup. I mean, these are all bundlers, right? uh, Build tools, or white, to refer to the process of eliminating unused code from the final bundle. Okay, so this is called tree shaking. So in React application or a JavaScript application, tree shaking ensures that only the part of the code that are actually being used are included in the build. Okay, making the output smaller and more efficient. Now you just think how important is this concept, right? So whatever the artifacts that you're creating, um, the size of that artifacts is all dependent on this concept, which is called tree shaking. Okay, so tree shaking ensures that the only the parts of the code that are actually being used are included in the build, making the output smaller and more efficient. So let me explain you with a real life analogy, as I always explain. So let's say you're packing a trip, okay? You're packing for a trip. So imagine you're preparing for a weekend trip, and you have a large wardrobe at home, okay? So your wardrobe, it could be a code base, contains all your clothes, including items for all seasons and occasions like jackets, swimsuits, formal wears, etc. Packing for a weekend trip, building the app, let's say. You can correlate like packing for a weekend trip with building the app. You only need specific items for the trip, isn't it? Yeah. So for a summer beach vacation, you might only need shorts, t-shirts, or flip-flops. You wouldn't pack a winter coat or formal suit, isn't it? Tree shaking, code elimination. During packing, you concisely exclude the items you don't need for the trip. Similarly, tree shaking eliminates the part of the code base that are not used in the application, ensuring only the necessary clothes are included in the final showcase. All right. So how it works in React? So in React, you might have utility like, for example, const add equal to a comma b, then give it arrow a plus b. This is a very basic function, right? So when if you import add only add function in the component, okay, so a bundler with the tree shaking enabled will analyze the code that and realize that subtract and multiply are not used anywhere. Okay, so for example, let me explain this way. Let's say you have a utilities.js, and there you have defined add, subtract, multiply, three methods. All right. Now, when you use only add in a particular class, when you are importing add method in a particular component, so this is the responsibility of the bundler, not to add or not to add all those methods as part of the lab code, because those other methods are not used anywhere in the application. So those unused exports will be removed from the final bundle. So anything which you have exported, but if that exported things has not used anywhere in the application, what is the purpose of being, it will immediately, it will very intelligently, I mean the tree shaking concept very intelligently remove all those unused export. Why it matters? Without tree shaking, just imagine all the unused code would still be included in the file bundle. So let's say you got your application. Okay, in that application, you are exporting, let's say 200 things. Okay, it could be functions, component, many more things. And out of those 200, only 100 or 80 functions are actually imported or somewhere used, others not. Then what is the purpose of having those in the code? So that is where tree shaking comes in. All the unused code would still be included in the final bin and increasing the app size potentially. So smaller bundles, faster downloads for users, better performance, reduced JavaScript parsing and execution time because you're cleaning it, you're moving it, cleaner code, of course. So yeah, and now it makes the very key requirements for tree shaking to work. So ES module syntax, like it works with import and export because they are statically analyzable. Okay. Bundler configuration. So ensure your bundler is configured to enable tree shaking. Example mode production. Okay. When you write mode production in Webpack, it will automatically enable your tree shaking terminology. It will make sure that whatever export, if not imported, just remove that from the code. Okay. So this process, much like smart packing, ensures efficiency, prevents carrying unnecessarily baggage. I hope you understood this concept. Let me quickly jump to the next one, which is called used layout effect. It is very important concept in Java, in React application. So let me quickly explain you this use layout effect. What exactly is this? So use layout effect, again, if you see here, this is coming from React, right? We have use effect also, we have use layout effect, use ref, many other things. So use layout effect hook in React is a specialized effect hook that fires synchronously after all DOM mutations, but before the browser paints the screen. Remember, the line which is very important to understand is that this hook is a specialized hook that fires synchronously after all DOM mutations, but before the browser paints the screen. But before the browser paints the screen, this makes it useful for tasks where you need to measure or modify the DOM before the user see the real changes. All right. So before the real DOM painting works or the real DOM renders, this is something which can really significantly play a real role. So what are the important characteristics if I explain you? So first thing is, as I said, it runs synchronously after the DOM changes. Second is ensures any changes made in the hook are applied before the screen is updated, right? What exactly before means, I'll explain you in a bit, right? So before the screen is updated, those changes are applied in the hook. It is used for scenarios where a flash of incorrect content must be avoided. So let's say there is something going on, right? And you do not want your screen to be updated immediately because there might be some errors. So you have some scenarios where a flash of incorrect content, they can create very uncertainties or bad user experience. So you want to avoid those. So for example, adjusting layouts, animations, or resetting focus and things like that. So those are very important thing. Now, most of us might be wondering what is the difference between use effect and use layout. Yes, they are more like kind of connected, uh, not directly but indirectly. So use effect, it runs asynchronously, meaning after the DOM updates and browser paints the screen. So whenever the DOM updates and browser painting is done, then whatever you do in use effect, it runs, right? But use layout effect, it blocks the browser paintings until its work is complete. So whatever you have in use layout effect, it will block the browser's painting. Browser will not render anything until its work is completed, which is in the use layout effect, which can make it more suitable for critical updates. Okay, let's say you want some critical updates to be done even before your screen or browser painting is done, right? But so any critical updates, but should be used judiciously to avoid performance bottlenecks because, of course, you're adding some delay, right? So as I always follow the practice of giving a real life analogy, over here I'll say one a very examples. Imagine you're hosting a dinner party, okay? All right. So before guests arrive, you rearrange the dining table and chairs to look just right, isn't it? That is the practice that everyone follows. So before even the guest arrived, you arrange everything, dining table, chairs, and all those things. So use layout effect is like arranging the furniture, critical adjustment before opening the door, ensuring guests only see the final layout, isn't it? So now you can correlate it with the React DOM. Yes, you got it right. So before even the DOM is prepared, DOM is rendered, you just make sure everything is all good in the use layout. In contrast to use effect, would be like making adjustment to the table layout after the guests are already in the room. So you might have seen sometimes what happen, guests arrive and then you are making the changes, right? You are making changes into adjustment into table layout, for example, fixing the table clothes and things like that. So this is all something which happens in use effect. Use effect, once the DOM changes and updates are done, then whatever you have in use effect takes executed. But use layout, it runs before the DOM update really happens or any painted app. Okay. So let me quickly explain you the code here. Okay. We'll see in the browser in real app how exactly these two are making an impact. So, okay. So use layout here. So what is happening? So this use layout effect, it sets one input ref current value to this was set by use player, and then you're making the color red, right? It immediately visual changes before the paint. So you see here, so this paint color, background color red, it happens even before, it should happen even before you done those changes, like done those changes onto your browser. So when you just run this, I clicked on use layout, you see it was red and then blue. Okay, so what happened? So this particular thing was executed first, even before your DOM was updated, meaning even before your DOM, when your DOM was updated, this is your DOM, right? So let me quickly do it again. So you see, okay, see that? So even before your DOM was updated, this was actually this got executed, right? Uh, okay. And whatever you see here, input ref, this is what you get it from here. Okay. So that is why whatever you see in this set use, this was set by use layout, is what is happening here. Okay. So this is happening in the very beginning, okay, even before your DOM is updated. So that is the reason why you always see input ref, the value which is this was set by use layout. Now after a certain timeout, okay, this document dot this happened, and that is the reason why I just put it with a little delay, so that you get an idea about how exactly this rendering is happening. So I think you got it now. So anything which is inside use layout will appear before the browser renders the input field. Okay. So if I, let's say, remove this and I just put it here, and let's say I remove this, or let's even if I do this, okay. So now if you see the same example, so see, okay. So in the beginning when you saw that, so since input reference was null, okay, and this used layout was not making any changes into this, so that is why everything which was inside this, it took the place, it was waiting till the whole browser renders, okay, and then only it changes the color to blue. So see here, there was nothing in the placeholder, okay, and once the placeholder was updated, then the color got changed. Okay. So this was red, there was nothing into the input reference, okay, and that is the why it was all like blank input box. But once this browser update happens, then only the color got changed and this value was updated. All right. So you see here one more time, this was set only when use effect executed. I think you got the concept right. Use layout effect and use effect. So next topic is memo with functions. So you already got with with one example which I shared with React.memo, okay, which is used mostly with the, I mean, of course, this is used for making your components memoization, but you also have um, something which you can use, for example, use memo, which is a hook. This is also a very important thing which you must always remember. So, okay, so let me quickly explain you about use memo. So, use memo, okay, is again one of the very important, a very good hook given by React. Okay, and uh, let me quickly explain you. Like this is also used to memoize, but this is used to memoize your functions. Okay. Um, Now you must be wondering when I say use memo is used to memoize function, then what callback do? Because callback was something also the similar, right? When I explain you the callback, you can watch my previous video. So what exactly the difference between use memo and use callback, how those two are different? I'll explain all those things in real with the code work and in the console also. But before that, let me quickly explain you uh, the real life analogy for whatever we are doing here, and then only you will understand, right, what exactly use memo. So uh, React.memo, as you already see, it prevents the child component from re-rendering unless its props changes. Okay. uh, Use memo for the callback here, I mean for any method, is wrapped, whichever method you're wrapping in the use memo, this ensures the same reference to the callback function is returned unless the dependency changes. Okay, so same reference. Uh, so for example, imagine you're running a bakery, okay, with a helper. So the child component, let's say, is your helper. So your bakery has a click to buy feature for a customer to buy cookies. Okay. So buy the cookies, meaning the callback. However, every time you bake a new type of pastry, increment the count. You don't want unnecessarily reminders to the helper about the same cookie sale mechanism. Unless it is had, it is actually changed. So why? Because this saves energy and avoids unnecessary communication. So the parent component is the bakery owner. Okay. The child component is the helper. The callback function is the cookie sale mechanism. Use memo over here. It ensures the mechanism, meaning the callback functions, doesn't change unnecessarily when you are just incrementing the count. And React memo optimizes the child component. So it does not re-render unless its props actually change. Okay. So let me quickly explain you with this example. Okay. Over here. So as I said, React.memo, this particular part is making the child component, prevents the child component from re-rendering. Okay. So this child component will not re-render unless the callback, I mean, the props to this methods, they are not changed. Okay. So without this React.memo, the child component would re-render every time the parent re-renders. Okay. For this, I would definitely refer you to watch my video, the part one video where I have covered very important or very easy to understand way of understanding React.memo. Okay. So use memo over here, the callback function is wrapped in use memo. You see this use memo. Okay. You can pass the dependency array here. So this ensures that the reference to the callback function is returned unless the dependency changes. Okay. The same reference is returned. So if you didn't use memo here, what will happen? Instead, define the callback directly. So this child would re-render every time the parent re-rendered because the callback reference would change, because this callback reference will change every time. And if this callback reference is changing, this child component is rendering every single time. Okay. So the parent maintenance account, which is here, every time you click a button, you increment the parent count. Okay. Yes. The parent re-renders, of course, it will re-render. All right. Uh, but thanks to use memo here, this method, okay, react.memo and use memo, the child only re-renders if the prop, meaning callback change. So over here, we're using use memo. So this callback will never change and this will not be rendered multiple times. This will never change and this will not be rendered multiple times. So let me quickly show you into the console how exactly this is working. So memo with functions, yes. So memo with functions. So you see here, I am clicking increment parent count. So there is no update. Even let me quickly add this also so that it's clear to you that count is getting updated. Okay. Now you see this is updated, but there is no print for rendering the child count. So child is rendered only once. This is not rendering multiple times. All right. So this is happening all because of this component is memoized using read.memo. And why this memoization is working? Because we are not changing the props, this callback. And why the props is not changing? Because this callback, the method is wrapped into use memo, which makes sure that the reference to this method is always same. It does not change. And when this reference is same, this will not re-render. And that is why we do not see here, even if the state parent state change, right? So if I click here, button click, and then click here, even then you see it is not rendering. The child component is rendered only once. Now, most interesting concept, which is use memo, okay, as a hook, and use callback. Now, most of us might be wondering, hey, what is use callback and use memo? Why not use callback instead of use memo? So I will explain you this here. Use callback specifically meant for memoizing functions. Okay. It is equivalent to use memo, but more semantically clear when working with functions. Okay. Use memo designed for memoizing values, but can also be used for functions. So key difference here is while you can use callback here, use memo used in this example because the intent here is to memoization the callback, but also want to show the use memo so that you understand what this is doing. Practically, use callback is essentially a specified version of the use memo for functions. You should definitely use callback for more semantically more appropriate for functional equivalent, right? So conclusion of this, yes, you can use callback. Okay, in this example, it would be more clearer since the goal is to memorize functions. So we just use memo here. So that's pretty much all when it comes to use memo hook. Now coming quickly to this part, which is called controlled and uncontrolled components. This is also a very important concept, right? So controlled and uncontrolled um components in React, they can be compared to managing forms or inputs in real life scenarios. So again, let me give you a real life analogy. Before for example, explain you anything technically, let me explain you with real life. So imagine again a barista taking coffee orders. So barista writes down each order on a notepad like state in React. Okay. As the customer speaks, if the customer changes their mind, the barista updates the order in the notepad before preparing the coffee. Right. So barista always relies on the notepad to know the exact order details. So barista, where it relies? It relies on the notepad to know the exact order details, how it relates to React. So in controlled components, the input value is explicitly controlled by React state. So for example, you see here value on change. So this input value is explicitly controlled by React state, which is over here. Okay. So the input value is always derived from the state, and any change to update the state, keeping in the React in charge of the value at all times. So input value is always derived from the state. So this is what control. Now, uncontrolled analogy here is, now imagine a self-serve coffee kiosk, right? The kiosk has a whiteboard where customers can write their order details. The kiosk doesn't know the details until the customer finishes writing and presses a button to submit the order. Okay. So the customer has full control over what they write, and the kiosk only checks the whiteboard when it needs to process the order. Now, how it relates to React? In uncontrolled components, the input value here, you see, is managed directly by the DOM. So this is where you used useRef, and useRef is directly managed by DOM. The browser handles the value. So React only access this value using the ref when needed, such as during form submission or validation, while in controlled component, it is handled with React state. All right. So I quickly explain you. Control component managed by React state, uncontrolled component managed by DOM. In control component, as I explained, barista writes and manages order onto a notebook. Uncontrolled component, customer writes order on whiteboard, right? So control component for dynamic and complex form validation, uncontrolled, for example, for simple form or legacy code. Controlled component, more explicit and predictable. Uncontrolled component is like less code but less control on that. So that's pretty much all when it comes to control and uncontrolled components you see here. All right. Uh, React Dev Tool, I just do not want to cover here because this needs a separate session to explain you React Dev Tools, which is a very important concept. You must understand about some Chrome or browser plugins before you use the React Dev Tools. I will also explain you how you can use React Dev Tools to understand a React page, components, the complete hierarchy structure or tree-like structure. So thank you very much for watching this video. If you like my videos, please refer my previous videos as well. Put your comments, subscribe my channel. Thank you very much. I see you in the video.